Okay, I'm going to record for A1001, the planet simulator. So this is basically my code. I'll run both the days and the years just to get it, but while doing that, I'll talk a bit about the code. So we're going to go ahead and see sim days for 1,000 days and 1,000 years. So I'll go ahead and run it. It should tell me the distance. But this is the planet class. We're going to have an initializer. We're going to have a position. We're going to have an expo finder. And we're going to have a distance. And this distance is going to use the Euclidean distance. So just x squared minus x1 plus y1, y2. So we're going to go that distance. And we're going to simulate it. So you can see that the value of Mars is 6.5. Right here, 6.5, which I believe is in here. So in sim days, you can see right here we're just grabbing the planet day in 732, and we're going to grab Mars, and we're going to get the average. So the position and distance functions, as I said, position is just we're gonna grab the degree, get 360 since that's how many times it's gonna rotate, and then we're gonna divide by the length that we're given. We're gonna go ahead and create our theta, which is the angle between the planets when we're sort of rotating, and we're gonna get that by multiplying the day by the degree. We're gonna get our theta in radians using the math library, and then we're gonna grab the radius. We're gonna multiply the radius with the cosine and sine to get y, x, and y respectively. And that's basically trigonometry functions that I used. So for the 1,000 day averages, so these are the noisy distances from Earth. So you can see this right here, going like this. You can see that the averages here, so Mars has the higher average, Venus has middle, and then Mercury has the lowest. You can see that there is a similar pattern. Mercury definitely seems to go over 360 a lot, right? It's sort of really shaky. Mars has a longer one, and so does Venus. And so you can see like maybe every, 100, 150, 120 cycles, you can see Mars going around. Yeah. So, and then you can also go ahead and, so this will run the matrix, but while while that's running, I want to go ahead and show that, well, I'll rerun and show the ranking, but actually maybe that now. So if I run this again, and, stop and rerun. If I change S here, in sim days. So if I change this to, let's say, 3.5, you can actually see the mean changing. So let me go ahead and rerun. So you can see that the mean changed to 18.244. This is obviously because S is being changed, and so we're increasing. So we're going to grab an increase in terms of mean. It's small, but it still does increase. And you can see that average also changes right here. So these three lines are different from last time. And then I'll run this. And so basically what's going to happen here is it's going to run through the years. And so in doing so, it's going to go through, I created the planets, and then I put them in a list. I created my zeros to fill out. And for each of the day, using the TQDM to get kind of this nice looking graph, it's going to go through all the distances, and it's going to fill out ij, ji, and this is going to avoid repeats right here. So it's going to fill out ij, but it's also, so for example, if we have 2,4, it's going to fill out 2,4, but it's also going to fill out 4,2 to sort of get both, right? Because if you have an 8x8 array, then yeah, you can fill out both of those as you're going along. Okay, and now you can see once it's done loading, you can see that it's symmetrical, but also that the planet's closest to Earth on average is Mercury, so same thing as the graph from last time. And this is the table, 8x8 table that's filled out. And you can also check that it's symmetrical, so yeah.